Hello everyone. And welcome back once again to another interesting video. In this video we'll discuss the most commonly asked Python interview questions and answers which will help you excel and bag amazing job offers. Each question is accompanied by explanations, tips, and examples to help you prepare thoroughly for your interview. So if you are ready, let's start today's video. Question 1. What is Python? And what are the benefits of using Python? Answer. Python is a high-level, interpreted programming language known for its simplicity and readability. It was created by Guido van Rossum and first released in 1991. Python's design philosophy emphasizes code readability with its use of significant whitespace and clear, expressive syntax, which makes it an excellent language for beginners and experienced programmers alike. Some of the key benefits of using Python include: 1. Readability. Python syntax is designed to be clear and readable, making it easier to write and understand code. This reduces the cost of program maintenance and development. 2. Versatility. Python is a multipurpose language, suitable for various types of programming tasks, including web development, data analysis, artificial intelligence, machine learning, scientific computing, automation, and more. 3. Large standard library. Python comes with a vast standard library that provides support for many common tasks and functionalities, reducing the need to write code from scratch and speeding up development. 4. Community support. Python has a large and active community of developers who contribute to its ecosystem by creating libraries, frameworks, and tools. This community support ensures that there are resources available for almost any programming task. 5. Portability. Python is platform independent, meaning that code written in Python can run on any operating system with minimal or no modifications. 6. Interpreted and interactive. Python is an interpreted language, which means that code execution occurs line by line, allowing for easier debugging and testing. Additionally, Python's interactive mode enables developers to experiment with code snippets and explore language features quickly. 7. Integration capabilities. Python can easily integrate with other languages and platforms, making it an ideal choice for building complex systems that require interoperability with existing technologies. 8. Strong support for data analysis and scientific computing. Python has become the language of choice for data scientists and researchers due to its extensive ecosystem of libraries and tools for data manipulation, analysis, and visualization. Overall, Python's simplicity, versatility, readability, and strong community support make it a popular choice for developers across various domains and skill levels. Question 2. What is a dynamically typed language? Answer. Python is dynamically typed, meaning that the type of a variable is determined at runtime rather than at compile time. In dynamically typed languages like Python, you don't need to explicitly declare the type of a variable when you define it. Instead, the interpreter determines the type based on the value assigned to it. For example, in Python. Here, the variable x can hold different types of values at different times during the execution of the program. The type of x is determined dynamically based on the value it currently holds. This dynamic typing feature provides flexibility and allows for rapid development because you don't need to worry about declaring variable types explicitly. However, it also means that you need to be cautious about type-related errors that might occur during runtime, as the interpreter won't catch them until execution. In contrast, statically typed languages require explicit declaration of variable types, and type checking is performed at compile time. Examples of statically typed languages include C, C++, Java, and C#. Question 3. What is an interpreted language? Answer. An interpreted language is a type of programming language where instructions written by the programmer are executed directly, without the need for compilation into machine code beforehand. Instead of compiling source code into machine code, like in compiled languages such as C or C++, an interpreter reads the source code line by line and executes it on the fly. Examples of interpreted languages include Python, JavaScript, Ruby, PHP, and Perl. These languages are often favored for their ease of use, rapid development, and platform independence, although they may sacrifice some performance compared to compiled languages. Question 4. What is PEP 8 and why is it important? Answer. PEP 8 stands for Python Enhancement Proposal 8. It is a style guide for writing Python code, authored by Guido van Rossum, Barry Warsaw, and Nick Coughlin. PEP 8 outlines coding conventions and recommendations to ensure consistency and readability in Python code. The primary goals of PEP 8 are to make code more understandable and maintainable by developers across different projects. Here are some key aspects of PEP 8 and why it's important. 1. Consistency. PEP 8 provides guidelines on how to format Python code consistently. Consistent code style makes it easier for developers to understand and maintain code written by others or by themselves at different times. 2. Readability. The guidelines in PEP 8 are designed to enhance code readability. Readable code is crucial for collaboration, code reviews, and debugging, as it allows developers to quickly understand the purpose and structure of the code. 3. Community standard. PEP 8 is widely accepted and followed by the Python community. Adhering to PEP 8 ensures that your code is familiar and comfortable for other Python developers to work with. 4. Tool support. There are various tools and plugins available that can help enforce PEP 8 conventions in your code base. These tools can automatically check your code for compliance and even format it according to the guidelines. 5. Maintainability. By following PEP 8 guidelines, you make your code more maintainable in the long run. Consistent formatting and naming conventions reduce cognitive overhead when revisiting or modifying code, making it easier to spot errors and make changes. 6. Professionalism. Adhering to PEP 8 demonstrates professionalism and attention to detail in your code. It shows that you care about producing high-quality, readable code, which can reflect positively on you as a developer. Overall, PEP 8 plays a crucial role in ensuring code quality, readability, and maintainability in Python projects. Following its guidelines helps create a more enjoyable and productive coding experience for both individual developers and collaborative teams. Question 5. What is scope in Python? Answer. In Python, scope refers to the visibility and accessibility of variables within a program. It defines where in the code a particular variable is accessible and where it is not. Understanding scope is crucial for writing clear and maintainable code because it determines the lifetime and visibility of variables. Python has the following types of scopes. 1. Local scope. Variables defined within a function have a local scope. They are only accessible within that function and cannot be accessed from outside. Once the function completes execution, local variables are destroyed. This is an example of how to define and use local scope variables in Python. 2. Enclosing or non-local scope. If a function is defined within another function, the inner function has access to variables in the outer function's scope. These variables are neither local nor global, they belong to an enclosing scope. This is an example of how to define and use non-local scope variables in Python. 3. Global scope. Variables defined at the top level of a module or explicitly declared as global within a function have a global scope. They are accessible from any part of the module or program. This is an example of how to define and use global scope variables in Python. 4. Built-in scope. Python provides a built-in scope that contains names of built-in functions and exceptions like print, len, typeerror, etc. These names are accessible from any part of the program. This is an example of how to define and use built-in scope variables in Python. It's important to note that while global variables can be accessed from within functions, modifying them within functions requires the use of the global keyword to explicitly declare that the variable is not local. Additionally, modifying variables from an enclosing scope within nested functions requires the use of the non-local keyword. Understanding scope helps prevent unintended side effects and enhances code clarity and maintainability. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.